just deploy it is not a strategy. It's a wish. Let's start right there, because honestly, that is the brutal truth we have to face today. For the past year or so, we've basically been living in this vibe coding phase, right? Development teams are leaning heavily on AI copilots to just crank out logic. And hey, it's amazing. You're scaffolding apps, generating APIs, and pushing out minimum viable products in literally days instead of months. But today we're moving past that honeymoon phase. We need to look at what it actually takes to survive out there on the open internet. Because the hidden reality of 2026 is that most projects, they aren't failing because of bad code. They're failing because the infrastructure, the environment they actually run in, is completely wrong.
So welcome to this explainer. I'm putting on my senior infrastructure consultant hat for this one, and I'm speaking directly to all of you software development teams. My goal today is to show you exactly why building a fast AI-assisted demo on your MacBook is an entirely different universe from running a hardened, secure, truly production-ready system.
Here is our roadmap for this explainer. We're going to cover 5 key areas. First, the laptop trap. Second, welcome to production reality. Third, defining production ready. Fourth, Cloud VPS control strategies. And finally, specific deployment use cases. Let's jump right in.
All right, section 1, the laptop trap, and exactly why those local builds collapse.
We've got to address the elephant in the room. Your local environment, your local host, is just incredibly forgiving. Think about it. You have absolutely no hostile traffic, no massive dependency outages to worry about, 0 real DNS latency, and absolutely no pressure from monitoring alerts screaming at you. So your code works locally, and everyone in this stand-up is like, awesome, we're basically done. But production? Production is an absolute war zone. It's the real world. Real users bring massive concurrency issues. Hostile traffic brings credential-stuffing bots working around the clock. Out there, a tiny little memory leak means full-blown downtime. And a quiet, unnoticed backup failure, that means permanent data loss. This massive, gaping canyon between those two realities, that is exactly where most modern AI-generated projects just completely collapse.
Moving to section 2. Welcome to production reality. Real users, real threats.
The absolute second your service goes online, the illusion shatters. Your application instantly becomes a target, and it doesn't matter how perfectly formatted your AI-generated code is. As an infrastructure consultant, I see this literally every single day. Production is going to punish you. You'll have automated port scanners probing every single exposed endpoint within seconds, literally seconds, of your IP going live. Got misconfigured headers? They're going to get heavily exploited. And even if we completely ignore malicious attackers for a second, the environment itself is just brutal. A minor database lock can suddenly cascade into a total system failure. And that last point on the list, that's the one that keeps me up at night. An unnoticed backup failure that turns what should have been a quick 10-minute outage into a permanent, business-ending data loss.
Which brings us to section 3, defining production-ready infrastructure. It's all about engineering discipline over AI guesswork.
So what does production ready actually mean in the real world? Look, teams don't fail because they don't care. They fail because they just don't know what operational questions to ask. AI is amazing at generating an API quickly, but it absolutely does not generate operational discipline. To be production ready, you need to follow these steps. Number 1, establish a true security baseline. We're talking deep OS hardening and strict least privilege. Number 2, you have to configure firewalls and implement safe network segmentation so a random exploit in your web layer doesn't instantly hand over your database. Number 3, implement proper TLS. That means automated renewals, HSTS, and sane cipher configurations. Number 4, tune your monitoring and centralized logs so you can actually debug real failures in real time, not just guess what happened. And step 5, maybe the most absolutely crucial one, deploy backups that are actually tested along with safe rollback processes. Honestly, if you haven't tested the backup, you don't have a backup. That's what it takes to be ready.
All right, section 4, Cloud VPS control strategies. This right here is your foundation layer. To actually enforce that strict security and networking discipline we just went over, you cannot, I repeat, you cannot just throw your app onto some cheap generic hosting platform and hope for the best. You need a strategic control layer. A modern managed Cloud VPS gives you that exact granular control. You get full, unapologetic command over the operating system and its hardening level. You dictate the strict network boundaries and firewall policies. You get hard resource isolation for your CPU, RAM, and disk I/O, meaning some noisy neighbor on the same server isn't going to crash your app. It gives you the perfect environment for container orchestration and safe scaling. You get to choose stable, repeatable infrastructure, not just, well, it worked on my machine. This is how you ensure your environment behaves exactly like production from day one.
And here's the thing, the safest path forward in 2026 isn't rejecting AI, not at all. It's about pairing it properly. Human operational expertise plus autonomous AI agents equals secure execution. For example, when you look at platforms leveraging systems like VoxForce and Meta Agent OS, they are combining real, battle-tested human infrastructure knowledge with AI agents to speed up environment setup, generate complex configurations, and build out troubleshooting playbooks. The massive advantage here isn't just that an AI types faster, it's that the experienced human operator knows exactly what to ask for, what to double-check, and what's going to break, while the AI just handles the heavy lifting of executing it all without sacrificing correctness.
Let's wrap things up with Section 5, specific deployment use cases. We need to look at architecting for your specific workload. Honestly, grab a screenshot of this if you need to, because this is your ultimate cheat sheet. Your infrastructure strategies absolutely must match your workload. If you're deploying an N8N automation server, you've got to secure access with SSO or a VPN, lock down your IP rules, and tune those queue workers. If your team is shipping Docker microservices, you literally cannot survive without hardened hosts, a proper reverse proxy, lockdown secrets management, and image pinning, so random dependency update doesn't take down your whole app. Now, if you're launching AI inference products, and I know a lot of you are right now, your biggest, scariest threats are token theft and absolutely runaway bills. So your focus has to be on strict cost controls, hard rate limits, deep observability, and bulletproof API token security. And for SaaS platforms, you need ironclad separation between staging and production, highly safe database migrations, and crystal clear incident runbooks. You see the pattern? Every single workload requires its own tailored, hardened network and security strategy.
So what does this all mean for you? Look, the world is building software faster than at any point in human history. Almost anyone can generate a workable MVP today, but operating a reliable, secure, cost-aware system, that is still the sole difference between a project that scales into the future and a cute little demo that completely crashes on launch day. So, as we wrap up this explainer, I want to leave you with one pivotal question to take back to your software development team before you run your very next deployment. Are you building a project that survives or a demo that disappears? Take a hard look at your infrastructure, apply these strategies, and build to survive.